Good morning. Today we're going to talk about Module 5, Lesson 2, and we're going to talk about how sound travels. In Lesson 1, we looked at the Anger phenomena, and we looked at how a truck stereo could rattle the windows of a building. I found another video I want you to watch.
In my hand, I can make the bad guys good for a weekend.
So what they want to know is the air moving all the way from the sound source to your ears or to the window. So as the speaker starts backing up, vibrating back and forth, does the air molecule the speaker hit your eardrum? So to test that out, they put a cell phone in a plastic container and sealed it up while it was playing to see if you could still hear the sound. So you can try the same thing. You could do it in a plastic bag or you could do it in a plastic container. So the reason that they sealed it in the container is they wanted to show the difference between a closed system and an open system. In a closed system, it's sealed. Matter can't go in and out. So if you look at this flask, the matter is sealed in there. Nothing's going to come in, nothing's going to go out. But in an open system, matter is free to move in and out. So they're trying to make a closed system so we know that no air is actually leaving the phone and hitting your ear. So they go further with the testing, and they have some different things that they show you. And I made a video to help explain the labs. So we start with the same test that they started with, where we seal the phone in a container. But what we want to do is we want to test to see if matter is actually leaving while the phone is playing. So we take the same container, we play the music, and we measure the mass as the music's playing to see if air is leaving or if it's staying in the container. And if you look at the mass, it's 232.5 while the music's playing. So that means that no air is actually leaving the container, it's staying. The next thing they want to know is there other materials that sound can travel through? So you take the same setup and you put it underwater to see if sound will travel through water. It is really hard to hear. I don't know if you're able to hear that the sound was still playing through the water. The other thing that it shows is since the phone isn't wet, it's a closed system that no matter what's coming in or leaving that experiment. So the next thing that they did is they want to know, what if you take all the air out? And they do that by putting the phone in a vacuum and pumping the air out. That means that there'll be nothing around it. If you have a vacuum, it means you have no matter.
Hi, what's your name?
Hi, I'm Miss Thomas.
Awesome, Miss Thomas. I see you got a, what's that in there?
Cell phone playing music.
That's cool, and it's just like in this container. That's neat. But I see a tube hooked to it. It looks like you can like blow air in or take air out. And then there's this funny machine here. It looks like it's got a switch on it. And could you feel the side of that and tell us what it seems like it's doing when we turn it on?
I'll show you with a piece of paper.
Oh, that's cool. Oh, it like sticks to it. And yeah, it's pulling air out. So we're going to do that. We're going to hook that up to there, pull air out of that container, and see what happens. Again, we can still hear the sound right now. You push that up against there nice and tight. And here we go. Here, a little bit. Let's keep going a little bit more. A little bit more.
What we're trying to do is we're trying to get all of the air out,
Now let's let the air back in.
So take this out.
Yeah.
because even if there's a little bit of air, you'll still hear the sounds. So sound can't travel through a vacuum.
I think we may have to do that again. Oh no, I can hear it. Cool. I could hear it just a little bit though, even when we took all the air out. I wonder if there's still a little bit of air in there, but I could barely hear it.
I
Right?
agree.
Maybe get nice and tight and try again. And we could try it a couple times. All right, thanks. Thanks, Mrs. Thomas. Appreciate it.
Okay. The next thing they want to know is what happens if you take all the air out and you just have water.
Sound needs a medium to pass through it. The most common medium of sound is air. So if there is no air, a vacuum is created. So the sound cannot pass through vacuum. Let's try an activity of another medium of sound called water. So we'll take a bell. So this has a sound. To check it whether the sound passes through the water, first check the sound. It has a different sound. When we put it in the water, you can hear it. There is a change of sound because the water contains less amount of air than the surroundings. So let's try another well. It's given in the science textbook. Thank you.
So in your science notebook, you need to complete lesson 2, investigation 2. And it is, we know that sound can go through water, through air, and through the container. That's how we were able to hear the cell phone. Why can't it go through a container when the air is removed? Why can't sound travel through a vacuum? Is what you're explaining. Okay, now that you've written that, scientists refer to a medium is any matter that's needed for sound to travel through. Gases, liquids, and solids are all media that can convey sound, and sound requires a medium to travel. If there is no medium, sound won't travel because it is a mechanical wave.